All right. Good afternoon, everybody, or good evening.
Good evening, sir.
Good evening.
All right. So, good evening. All right. So, good night, Abby. So, we were on the topic of, assuming you guys are seeing my screen and everything. You guys are, sorry, last week, we completed functions, f of x, g of x, h of x. Did we do inverse? I don't think we did inverse. I think we were having so much fun. Well, I was having so much fun teaching the composite function. I don't think we did inverse. Confirm it for me, Miss Gentles. Oh no. Oh yeah, God, I said we didn't do it. Okay. So we are going to do two things tonight because last week I think I overtaught that topic. So tonight's objective is going to be, hold on, give me a sec, let me just pull this up. Okay. All right, let's put a head in here. So the objective for tonight is going to be inverse of a function and hopefully, not hopefully, we will, and completing the square.
Sir,
Yes.
did you do combined?
Yeah, I did composite function, yeah. Oh, combined. Oh.
Yes, sir, because I saw that on the list.
Okay, so I'll do a couple of examples of combined functions tonight. So completing the square. I'm going to do a little bit of recap from last class. All right, so inverse function and completing the square. It's the topic for tonight. Is Jaden in here? Jaden? Jaden? He's not here as yet. Okay. All right, so inverse of a function and completing the square, that's the objective for tonight. Let's do some quick recap from last class. So in our last class, we looked at composite function, but I'm going to do an overall recap of everything thus far. So let's say, guys.
Your mobile Minecraft. The cool thing about them is that they are totally different.
Dominic. Okay. All right, so if you're given a function, let's say that you're given, say, f of x is equal to some function. I don't know. Let's make up something. Let's say x plus 5 over 3. And let's say that you're given g of x is equal to, let's say, x squared minus 1. Something like that. X squared minus 1. All right? And they're going to ask you a bunch of questions about it. All right? So they may ask you questions like, 1, what is f of, say, f of 4. Yeah, sound good. Something simple. We're not trying to do nothing too crazy. So f of x is equal, so f of 4, that's one question, right? And they may ask you what is, say, g of, say, minus 2, something like that, all right? And you may, Zahinia? Okay. All right, so f of 4 is, f of 4 and g of minus 2. And you are also asked to work out something like number 3. Let's say you're asked to work out f of g of, let's work out f of g of x. And let's say that we were asked to work out, say, g of f of x. Right? G of f of x. All right, so g of f of x. Let's work out these. So f of 4, what does that mean? This is a direct function. So that means you are directly going to be substituting the 4 right here. You're going to put the 4 where the x is, right there. So you're going to end up with 4 plus 5 over 3. That works out to be 9 over 3, which works out nicer to be 3. Very easy. Very simple. All right. And at the bottom, g of minus 2, same thing. You're going to put minus 2 right there. Right? Put minus 2 right where you see I send the arrow, because you're putting the minus 2 for the letter x that is in the g function. So you're going to go ahead and you're going to say minus 2 in bracket, and you're going to square that, take away 1. So that's going to be 4, take away 1, and that's equal to 3. All right? Very, very simple. So that's direct function. Now, composite function now is where you're actually putting a function into a function. Now, notice that there's no number here. So there's no number to put into anything. All right? So in this case now, what's going to happen is that what this means is, this literally means that you're going to be putting the g function into the h function. So what do you mean by that? Put the g function into the h function. Look at what I'm circling. I'm going to circle this thing right here. Right? That thing there, I'm going to be replacing the x all the way over here with all of what I've circled. So I put a circle around that. So I'm taking the g function, I'm taking the I'm taking the expression that represents the g function, and I'm going to put it all the way where the x is over here. So that simply means that if I see an x over here, like right there, I'm going to put this thing right there. Okay, so I'm going to end up with x squared minus 1. Miss Grace, and I think you have to leave the class and then come back. I don't hear nobody else, they're not hearing me. So you have to exit the class and come back. Somebody can text in the chat and see, tell her to exit the class and come back. Please and thank you. All right, so we're going to take x squared minus 1 and place it there. So we're going to end up with x squared. Oops, sorry guys. X squared minus 1, right? That goes right here, right? That's all. Not true? All right, and then we're going to add on the plus 5. And we're going to divide all of that by 3. Okay? So that's going to work out nicely to be x squared plus 4. Right? Minus 1 plus 4. Sir, how is minus 1 plus 4? Isn't minus 1 plus 4 6? Nope. Nope, 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 nope. Minus 1 is negative. You owe 1. And you have 5. You pay the 1, and you have, out of the 5, you still have 4 left, and that's going to be over 3. Simple. Nicely, nicely done. Okay? All right. So the next one is a little trickier, right? A little trickier. Watch this now. So we're going to put now, I'm going to erase this now. Watch. I'm going to erase this, erase that, and that. Okay? So look at what I'm going to circle now. I'm going to take this now, right? Because today, this is the one that's right here. I'm going to take that function. I'm going to put it right here. It's the opposite I'm doing. So gfx, I'm going to put that thing right there. So this x plus 5 over 3, I'm going to put it right here so, and square it. So I'm going to hit x plus 5 over 3. I'm going to square that. Square everything here. And then we're going to end up with taking away 1. Okay? Now this requires a little bit more simplification in case they give you something like this. Alright? So in case they give you something like this. So don't bother go square the x and square the 5 and talk about x squared plus 25, you know. Hey, Shineke, do not do that. This means x plus 5 multiplied by x plus 5 all over 3 squared minus 1. What? Sir, oh, you just do a while ago. This square means that I'm going to, okay, what if I were to ask you, what is 1 over 4 squared? What would you say? If I ask what is 1 over 4 squared, what would you write? You'd say what? 1 squared over what? 4 squared. Not true? So the answer would work out to be 1 over what? 16. Not true? That's what you should do if I gave you a fraction to square. So what is the big difference between squaring a numerical fraction and squaring an algebraic fraction? They're the same thing. So In this case now, you're going to end up with x plus 5. You can't square the x and square the 5. They're not individual terms. You're one term. So x plus 5 is one term. So x plus 5 should multiply itself over 3 squared minus 1. Now, can anybody recall me teaching something like this? First with first, first with second. Oh, Lord. First with first, first with second, second with first, second with second. It's a technique that I taught you sometime last year called foiling. Okay? So you're going to end up with something like that says, and this is one of the more complicated examples. X times x is x squared. X times 5 is 5x. 5 times x is 5x. And 5 times 5 is 25. So look, you go first with first. Then you go first with second. Then you go second with first. Then you go second with second. And that's going to be all over 9 minus 1. Simplify this. I'm going to leave it as here. I'm going to end up with x squared minus 25x plus 5 over 9 minus 1. I can leave it right here. I don't have to. I can go further if I want to, but I don't want to. So I'm going to leave it right there. Okay? Now, as I said, the complexity of the question heavily depends on the type of function given. It depends on the function, right? And like I just made up that one in my head, so my apologies if it looks a little bit challenging, but yeah, that's what we do. Okay, so
Sir,
yes, question.
back to the number 3.
Mm-hmm.
I don't know if you did something when I was a bit distracted with the x square.
Mm-hmm.
You do something different.
So this
I end up
GFX.
with x with the x. You
So
have x
this
squared there, and then we see x plus 4.
oh, because the minus 1 plus the 5 is 4.
Mm-hmm. So to do with the square.
Right. Oh, Lord Jesus. Thank you.
Okay.
Okay, thank you.
All right. Okay, yes.
Thank you, thank you. All right, so that is basically a recap of what we did. All right, there's more. There's more. Who put in box on my screen? I know I'm beaten up. Who is putting box on my screen? I don't want to get beat up in this class. Okay. All right, lovely. Now, let's do some other examples that we did. Okay? Because the minute since we move too fast, you know, I don't understand what you're doing.
Sorry.
Yes. Geneva, take your hands off my. Do not write on my screen, Geneva. Yes, dear. Go ahead.
I'm confused.
Who is talking to me?
Tomorrow.
Tomorrow. Be quiet.
Sir.
You learned this in class. Have we? No, wait. Have we started
Sir,
it in
I
class?
didn't. No.
So wait. You have to wait until you learn it. These students learning this from last week.
Okay.
Oh, she's an invitee, guys. That's why she's asking the question. All right. No. Let's do something simpler. Let's do something like h of x. Oops. Sorry. Zoom up. All right. Look good. Lovely. All right. Here's another example. H of x is equal to x minus. Let's do 2x minus 2x minus 3. And let us do g of x is equal to. What can I do now? What can I do? All right, yeah. 2x, g of x equals x plus 1 over 4. Something like that. Right, good. Now, look at this now. Let's say that you were asked to work out h of g. Let's say that you were asked to work out h of g of h of g of 11. H of g of 11. Oh, Galia, this is what we call combine here. This is what
Okay,
combine
sir.
is. So we're doing direct mixed with composite mixed with inverse. Yeah. So hg of 11, that's one. And let us say that you were asked to work out something like number two right here.
Sir, just write combine at the top, please.
Okay. Combined functions. Okay, lovely. Oh, right there. Lovely. All right, so let's say we have something like h of g of 11, and let's say that you were asked to work out something like g. That one is interesting. Very interesting. Let's do h squared 2. All right. So that so this is basically composite mixed with direct. Composite mixed with direct. Let's say that you were asked these two questions as well. Find the value. Why am I writing it right here? Let's go down here. All right, let's say that you were asked to work out this one. So it says find the value of x for which 1 or a, I should say. All right, no 1, a. All right, so find the value of x for which a, h of x is equal to a half. And b, you have to work out what is g of x equals to -4. All right, let's take this on. So h of g of 11. What does this mean, ladies and gentlemen? We're going to put the 11. Watch me now. Watch how I go on. Watch the arrow. I'm going to take the number 11 and I'm going to put it into the function g. So I'm going to put 11. I'm going to replace the x that is in g, that's the x, right? So with 11. And then when I put 11 there, I'm going to work it out. It's going to give me an answer. When I get that answer, I'm then going to put that answer into h, which is right here. So watch again. I take the number 11. I'm going to replace it with, remember, if I ask you what is g of 11, what would you do? If that was the question, you would take 11 and you'd replace it with the x and work it out and get the answer. But now when I get the answer, I want you now to put it back into another function, which is going to be h. So what this means now, ladies and gentlemen, is that you're going to work out g of 11 first. So g of 11 is going to work out nicely to be 11 plus 1 over 4. Sir, where you get 11 plus 1? Look here, people. Right there, so. You see it right there, so. So me put the 11 right here, so. Right there, so. So we get 11 plus 1. And that works out to be what? 12. Not sure? So there it is. So 11 plus 1, that's equal to what? 12 over 4, which works out nicely to be 3. Not true? Now, this 3 here is the answer for this part. So we can replace g of 11 with 3. Now I'm going to end up having to work out what? H of what? 3. So h of 3 then works out now. I'm going to put the 3 right here. So for the arrow point, right there, so. I'm going to put the 3 right there, so. So therefore then, I'm going to end up then, whoops, sorry guys. I'm going to end up then with 2 times 3 minus 3. That works out to be 6 minus 3. So 2 times 3 is 6, right? Oh, yeah. 2 times 3 is 6, 6 minus 3. And that works out nicely to be what? 3 again. So that's your answer. Yes, question.
For g of x, why is it just plus 1 over 4? Where's the other number?
Sorry, it was erased by accident.
Okay.
It was x plus 1 over. Yes, so x plus 1 over 4. All right. So that's it. Now, I think we discussed this last week, this 8 square thing. Please do not square the h. Do not square the h and put 2 in it. No, someone, I like to invent new maths. Remember, 8 squared does not mean square the terms. 8 squared means h bracket hx. All right, that's what it means. So 8 squared means hx. That's what it means. So technically, I can rewrite this now and make it look better. I can say 8 squared x is the same thing as h of 2. That's what it means. So notice that the 8 squared gets split up into what? h like that. So 8 squared is h. Basically, it's kind of saying h times h, but that's rubbish. Okay, you can't say h times h in functions. Huh? You can't say a function times a function is a function squared. So, but it's kind of like that. You can interpret it like that. Okay, so h2. So what this means now, ladies and gentlemen, you're going to put 2 into h. Look at the arrow. Pay attention to the arrow. Look what I'm doing. I'm going to put the 2 into the h. It's going to produce an answer. Take that answer you get and put it right back into h again. So you're putting the answers twice into the same function. So this works out nicely to be 2 times 2 minus 3. That is 4 minus 3. That is 1. And then you're going to take back the 1 now and put it right back in the h again. Right this up because of 2h now. So that's h of 1 is equal to 2 times 1 minus 3. So that's equal to 2 minus 3, which is equal to minus 1. That's the answer.
Question.
Sure.
How does the 2 go into the h?
You replace the x right here with h, with 2. So that's 2, look, 2 times 2 right here. Look up top. So 2 times 2 is 4.
Because the
4
8x
minus 3.
equal
Yeah.
to
X minus 3.
2x
Correct.
minus 3.
Yeah.
So the h squared would give
The
you
h squared is just another way of writing the function.
of writing the same
So the
function.
h squared, correct. I could have just
Okay,
written this,
I see
I
it.
could
I
have just
see it.
written what is h of 2. See what I'm going. Okay, all right, cool.
Okay, yeah. So basically, it's if you put the 2 where the x is, you're actually putting 2 into 2.
Correct.
Yeah.
Lovely. All right. Now we are going to then go. We're going to go ahead now and find the rest of the thing down here. Now this one, now I believe we had mentioned it. I can bet this is Samara. Oh my god. So this one now
What did
is
I
going
do?
to be input output. Okay. So what we were doing a while ago is that we were putting something into the function, and the function was producing an answer. For this example down here, we have been provided with the answer. Oh Lord, sorry. We have been provided with the answer. And so we are trying to find out what number should actually go here. That's what we're trying to find out. So look at this now. All right. So what this is saying, when you read it, it is saying that this symbol right here, this h open bracket x, must be replaced with a half. That's what they're trying to say. So when you go back, let me zoom out a little bit. All right, good. So when you go back up here, right? Basically, what they're trying to say is that you should take the number a half and put it right here, so. Put a half right here, so. Not in it, Put the whole entire symbol here, should be removed and put a half. So we're going to end up then with, watch. We're going to end up with a half. See that? A half. And that's going to be equal to, look, all of this over here. Because this symbol here, you replace it with a half. That's what they said. They said that symbol is a half. So therefore, because that symbol is equal to 2x minus 3, then it means that a half must be equal to 2x minus 3. Now, by now, you guys should catch on to the idea of having a number at the bottom. We've done this multiple times. We're going to multiply both sides by 2. So remember, we said that whenever we have a number at the bottom, you multiply this by 2, and you multiply everything by 2, and multiply that by 2 as well. Okay? Whenever you have a number at the bottom, you multiply the whole entire function or the equation by that number. So look what happens now when you multiply by 2. This 2 cancel this 2. So you end up with 1. All right? And then 2 are going to multiply 2x, so you're going to end up with 4x. And then 3 are going to multiply 2, you end up with 6. Okay? All right. Now to solve this, you bring over the 6 over here. Sorry, you bring over the negative 6. You're going to get 1 plus 6. And that's equal to 4x. All right. And then say 7 is going to be equal to 4x. And if you divide both sides by 4, you're going to get a nice result. No, not really a nice result. I don't like this result, but okay. You're going to end up with a result of 4 cancel 4. So 7 over 4 is equal to x. That's it. Me actually over teaching, Normally I wouldn't teach you so much time, But you see, when it comes on the exam, I want you guys to nail it. All right? I will leave this one for you to do. All right? On your own time. Okay? But I have to move on. Spend more time on this. It's 7:43. All right. Now, here we go. So head up for me, guys. Inverse functions.
Sir,
Yes.
do I have to write all of this?
It will be better for you.
But I haven't learned it yet.
It will be better for you.
Okay.
All right. Okay. Ready, guys? So, inverse function. The inverse of a function is denoted by the inverse of a function is denoted by the following. The inverse of a function is denoted by the following. So what you're gonna, when you say inverse, then what you find, it looks like this: f minus 1x. Then you might see g minus 1x. You might see h minus 1x. And so on and so forth. It could be any letter. All right, so that minus 1 implies inverse function. That's what it means. That minus 1 implies inverse function. Now, how do we find this thing here? There's a 3-step process that we follow. Please write down these steps for me, guys. Step 1. First thing that you do when you get a function and you're trying to find the inverse of it. Step 1. We're going to let y, don't put y in open and close quotation because it's a letter. So don't write WHY. Simara, don't write WHY.
Sure, please.
Step 1, let y, or no, I shouldn't write it like that though. Write it on a different way. Same meaning. So we're going to replace, pardon me guys, we're going to replace the function notation with y. So what does that mean? I don't understand. What do you mean replace the function? What is the function notation? You remember this thing that I was showing you here? F of x. G of x. H of x. That's something here. This is what we call the function notation. So basically what they're trying to say is that you're going to replace, whenever you get a function, you're going to replace that symbol with the letter y. So this symbol right here, let me put a little red marker on it. This symbol and this symbol and this symbol, whichever one them use, you're going to replace it with the letter y. That's step one. Step one. Step two. You're going to interchange. You're going to interchange x with y. You're going to interchange x with y. Yes. You're going to interchange x with y. All right. And then the final step. You're going to make y the subject. So you need to isolate y. In other words, some textbooks or some teachers will say isolate y. It means that you must get y by itself. Those are your three-step process to finding the inverse. Let's do some examples. I'm going to start simple and then build it up. I'm not going to spend too much time on it because I want to use the last half of the class to introduce completing the square. Because like I said, I kind of overteach last week and I even came today and still gone back and overteach again. I don't know why I'm doing this. Maybe it's a reason why I'm doing it, Maybe CXC actually going to send this question in. I wonder. All right, here we go. So, f of x is equal to 5x minus 3. Find f inverse. Simple something. Now make it too hard. So we must find, hold on, let's write it to the side here. Find f minus 1 x. So, step one. Watch this now. Very easy, guys. I'm not saying it's easy because I'm a math teacher. I'm just saying it because it actually is easy. Look, so step one, replace this symbol right here with what? Y. So y goes there, and that's going to be equal to 5x minus 3. Step one, done. So easy that? All you have to do is just replace this symbol right here with y. So if a g of x, replace it with y. H of x, replace it with y. R of x, replace it with y. Sigma of x, replace it with y. Now, step two, we're going to interchange x with y. So what do you mean by interchange? Interchange means exchange position. So we're going to say, since y is here, put a x there. And since x is there, put a y there. And that's step two. Step three is the important step, right? And why it's important is depending on how difficult the function looks, that will determine how well your algebra is. Okay, so look at this now. Very easy one. Bring this over there because you want y to be by itself, So move this 3 to the left. You're going to get x plus 3 equal to 5y. And then you're going to go ahead and say x plus 3 divided by 5 is equal to 5y divided by 5. What? Sir, hold on, wait just a while ago. All right, hold on, I'm going to that. Come again. So because there's a 5 in front of the y, we're going to say 5y divided by the thing that you want to get rid of. And that's equal to x plus 3 over 5. Oh, okay, sir. I saw what you did. Cross out that. Therefore, y is equal to what? X plus 3 over 5. Now, ladies and gentlemen, so when you find y, Once the moment you get y by itself, you have obtained the inverse. So you just draw a conclusion and you just simply say, always draw the conclusion. Because remember that the question didn't say you must find y, no. The question says you must find f inverse. But we know that when we find y, we find the inverse. So therefore, you're going to say, therefore, stop here, f to the minus 1x, f to the, what is going on? F to the, f to the minus 1 x is equal to x plus 3 over 5. All right? Easy, easy. Any questions? No? Let's do another example. Good job. Yes, dear.
Where do the other part of it? Just leave
What's the
it.
part? What's the part?
You never turn one.
Huh?
I thought it was two parts. The X and pull up back the screen. It's up here.
See there, see me do it there.
Look,
See it. This answer here, when we get, me put it right as so. And this here is f inverse. The moment me get y by itself in Miss Gentles, I found the inverse now. So the thing I said,
is up here. I was looking at when you get this part and then you get this part. So I mean, I know me that thing say that become two.
Oh no,
when I
man,
saw this, I thought it was two different things, but I think I get it. All
get
right.
it now.
Yes.
Oh,
yes.
okay. Lovely. All right. G of x. Why am I using red? Me stop here. Okay. G of x. Watch again. I make it complicated. X squared minus 5. Oh, Lord. And we're asked to work out G inverse of x. Step 1. Let the function be replaced with y. The function notation. So look at the arrow where I pointed. This entire thing right here, so I'm going to move it. I'm going to put y there. Then I'm going to let that equal to x squared minus 5. So I've completed step 1. I've replaced the function notation with y. Step 2, switch the x and the y. So since y is right here, I'm going to remove that. I'm going to remove that that y. I'm going to put x there. And since x is there, I'm going to put y there and square it. Remember, see, I replace the x with y. So y squared minus 5. Objective, to get y by itself. Watch now. I'm going to bring over the 5. I'm going to end up with what? X plus 5 equals y squared. Can anybody remind me of how do I remove this square that is attached to the y?
Square root.
Excelente, sir. Excelente. So you're going to square root x plus 5. And that's going to be equal to the square root of y squared. Guess what happens? The square root cancels the square. So you end up with the root of x plus 5 is equal to y. The moment you find y, ladies and gentlemen, you have obtained the inverse. Therefore, G inverse x is equal to the root of x plus 5. Any questions? Silence is golden. I love silence. Silence means we can just teach some harder example. Yeah, man. Because nobody not saying, sir, I don't understand nothing that you're doing. That's good. That means I'm teaching well. Let's continue. Last example. H of x is equal to 2x minus 1 over x plus 4. The more complicated the function looks, is the more simplification is required. But the rules don't change. So, the question says that we should work out H inverse x. So, Mr. Peart, how do you do this? Here's what we do. Step 1, ladies and gentlemen, replace this symbol there that I pointed the arrow with y. Not true? And then y is going to be equal to that thing over there. 2x minus 1 over x plus sure. Can't put that. this technology thing with me now. X plus 4. All right, lovely. Step 2, interchange x with y. All right, so now y is here, put a x. Number the ball now, we know. Number the ball. A 2x there. That means you have to replace all the x's with y's. So even though you only replace one y with one x, a 2x, you have to replace them with two y's. Students said that to me one time, sir, you only replace one y with one x. Why are you replacing the 2x with two y's? Remember the instruction says interchange all x's with y's. That's what it says. Or interchange all y's with x's. So 2y, and that's going to be y plus 4. No. Hell and powder house, no. Hell and powder house, no. How do we get y by itself? Lord, prepare me to be a sanctuary. All right, okay, here we go. So you're going to put the x over 1 and you're going to cross multiply. Cross multiply. Oh, okay. Yes, Mr. Peter, I understand now. So you're going to cross multiply. So cross multiply meaning that I want to get this thing from down at the bottom here. I want to get rid of that thing down here. So I'm going to cross multiply. Write it down now, guys, because nobody forget, Cross multiply, write it here. Cross. Is that in here? She's not talking to me again from the other day.
Hey, sir. Yes, I'm here.
Okay. X times y is xy. Look now, we use the x here, people, and multiply this and this. Then 2 there. Oh, pay attention. No. So, x times y, xy, x times 4 is 4x. And then that is going to be equal to, well, obviously when you multiply something by 1, people, what you get back? If 1 times 10 is 10, 1 times 5 is 5, 1 times is a, 1 times Zahenia is Zahenia. So 1 times 2y minus 1 is 2y minus 1. And then multiply anything by 1, you get back the same thing. Okay? Therefore, now what we're looking for is y. We're looking for y, ladies and gentlemen, folks. Y. The problem with this question is that there is a y right here and there's a y right here. So, sir, which one must I solve for? You're going to solve for both of them. So, therefore, for you to solve for both of them, you will have to go ahead and group like terms. So, xy, we're going to bring this little guy over here. Come right over here, sir. Over there, we're going to get minus 2y. And then now, once I have the y's together, I don't really care about everything else. I'm just going to minus 1 over there and come over here, sir. Right over there. So that's going to bring minus 4x. So I'm going to shift it up. I'm going to put the y's on the left. I'm going to put everything else on the right. Remember, when you're moving stuff, do not forget to change the sign. Now, big question. Do you think I can subtract 2y from xy?
No, sir.
I wonder why.
Unlike terms.
Excelente. Unlike terms. Very good, sir. So if I can't subtract, there's a F word, and do not curse nobody in my class. There's a F word that I use. Factorize. Very good. So if you cannot subtract or add something to each other, you're going to factor it. So factor out the y now. Y x minus 2. What? Hold on, wait. Slow down, Mr. Peart. Why? You see, I have to be asking myself the question, you see, and answering it because none are talking to me. So I take out the y from these two, open the bracket. When I remove the y from here, I'm going to be left with what? X. And remove the y from here, I'm going to be left with what? 2. And that's going to be equal to negative 1 minus 4x. Therefore, if I divide both sides by x minus 2 and divide both sides by x minus 2, that cancel that. Guess what happened now, guys? Ouch. Cancel that. I cancel that. I'm going to end up with what? Y is equal to minus 1 minus 4x over x minus 2. All right? Lovely. 3 examples let me give you. See them there? You see them? 3 examples. All examples are the same. So this kind of depends on the complexity of the function. Okay? Lovely. All right. Lovely, lovely, lovely. Unfortunately, I don't have a single video on this that breaks it down. This is my first video doing this. Oh, I see that.
Sorry, so me not talk to you tonight though.
What is going on? What did I do now?
I'll talk to you, man. Okay, you hyped me up last week and then now you just come make a little switch. But may I go on.
Yeah, hang in there. Hang in there. It gets hard as we go through, you know? It gets more challenging, but it's okay.
No, it's not challenging. It's not.
Look at practice.
Yeah.
I see that 13 of you said that you're coming online. And then some of you guys coming to face and online. That's dope. I like that. So 4 of you say you're coming face-to-face. 4 of you say you're coming to both face-to-face and online. And then 13 of you say you're coming online. That's good. That's good. All right. Online is going to be nice though, man. I tell you, online are the thing. I love teaching online. Online, we get so much. I see because after we done the class, we can just export the file. It's almost like you have it's going to, well, to me love teach online. Online just give me so much flexibility, right? Because I don't have to write the questions, you know. I don't have to print. The questions are going to be on the screen. Anyways, now for the next 27 minutes, guys, I'm going to introduce you to a concept. So end of functions and relations, guys. That is the end of functions and relations for now. All right. So that means, look at this now. Hold on. Starting to behave like my lecturer, you know. He's such a dope teacher. My lecturer is such a dope teacher. So that means, ladies and gentle folks, look at this. All of my people, them now, you know, you can work them questions, you know. Look at 2025. You can work them now. See, say, frightened anymore. What them feel like? What did them feel like? Come scroll up. Go all the way down there and show them so we're not afraid of them. Come. Where them there? One there. Show 60 so we're not afraid of them. We're not afraid of Uno. Shoot them. I mean, Stacy, look at that. Bop. The inverse of the function. Bop. Look at that. Show them that f of g of x is that. So we know how we find f of g of x. You see that? We know how we find what? F inverse. No? We know what is what? Direct function. I'll pull up that. Can't frighten me. That's a 2025. Let's go to 2024 now. Look, we got the January paper. Shouldn't say we're not afraid of them. Not afraid of one beer. Think I can't frighten we. Think I can't frighten we. No question them send come go and them can't hurt chicken. Hold on. Wait, they not send on January? What is this? What is this? They didn't send any January? Hold on. Somebody's mic is unmuted. It's causing a bad feedback. Look at that. Hey, look at that. See that? Calculate the value of f of minus 2. How much marks that? 1 mark. We can call it that. Derive the function f of g of x. We do that already. Look at that. Oh my lord. Look at that. Oh my lord. Look at that. Oh my lord. See that? Derive an expression in terms of x for the inverse function. But like that. Now, one more. Go shut them. 2024. We're going all the way to me. One more. Anytime send them question, they come just deal with them. Look at that. Oh my god. Finding the simplest form of expression for f of x minus 2. Yeah, we can do that. Look at that. G of x. Look at that. We can do that. Yeah, we're good now, not true? We are right. Now we have to move on to another phase. All right. Lovely. So head up for me, guys. Completing the square. It's kind of going to be a little introduction. Next class, we'll expound on it a bit more. or the K? All right. Mr. Peart. Lovely. Now, completing the square. What are we doing? When they say complete the square, what are they asking us to do? What are they asking us to do, Lord? Completing the square. Oh, yes. And it doesn't mean so we're going to draw one square here. So completing the square. What exactly are we required to do when and if you see this thing? What are we required to do? Well, here's the objective. Write this down for me, guys. Completing the square is the method by which completing the square is the method by which a quadratic expression completing the square is the method by which a quadratic expression a x squared plus slash minus bx plus slash minus c is written in the form. So after you write, the completing the square is a method by which a quadratic expression, you write this thing right here, so after quadratic expression. After expression, you write that thing. By which a quadratic expression, ax squared, write it just like that, capital A, small b, small c. By which the quadratic expression, ax squared plus or minus bx plus or minus c, is written in the form by which a quadratic expression ax squared plus or minus bx plus or minus c is written in the form a open bracket x plus h all squared plus k. Oh Lord have mercy, Mr. Peart. How are we going to do this now?
Mr. Dear,
Yes.
repeat, please.
Everything?
No, from written in the.
Written in the form. That thing that is on the right. This thing right here. Written in the form, that thing right there. So.
Where's the A?
I didn't hear that, Samara. Sorry, me mute you.
Wow. Where's the A in the first part? You said the ax squared plus or minus.
Ax squared plus or minus bx plus or minus c.
I'm not seeing any A.
I don't understand what you're talking about.
I'm seeing a minus sign then an x squared.
I don't know. Jump out of the class and jump back in. I don't know. Is anybody seen that? Everybody seen ax squared plus or minus bx plus or minus c?
Yes, sir.
Yes, sir.
Yeah.
I have to scroll the screen.
Oh, okay.
Yes, sir.
Okay. All right, so ax squared plus or minus bx plus or minus c is identical to this thing here. How do we do this? Well, it's actually simpler than what you think it is. It does look hard, but it's not hard. Look at this. So the objective, ladies and gentlemen, is that we're going to try to find this number here, these numbers. This thing right here, this thing right here, and this thing right here, right? Those are the three things we're interested in finding. You're not going to find x, at least not yet. Your objective is to find those three letters that I've underlined. So the question now, sir, is how do we find them? There's a little formula that we use, right? And I'm cutting out the process of doing this. If you go on YouTube, or you type in completing the square, then I'm gonna teach you one whole different type of way. I just came up with it. Well, not I. the formula exists out there. Us mathematicians came up with a shortcut to complete the square real fast. And here's the shortcut. So this A right here, look at it. This A right here. This A is actually equal to this. So what? Hold on. So what do you mean by that? This small A right here, look at it. This, let me use an arrow. Give me a sec. Let me use an arrow and move around this thing right here. So you see this small A, look. You see this A right here, where you see me I move from, right also? This A right here, this A right also, this A is exactly equal to the number that's right here, so. Yeah, that's all. So this A right here, so, the value, the number we're going to put right here, so, is exactly the same number that is right here, so. Pretty much that's what I'm trying to say. So small a is small a over here. So the small a over here, this small a is exactly equal to this big A right here. So when you get the expression, that's the first thing. Let's put that now in like a box. All right, lovely. Now, this H right here, so H, the H value, the number you're going to put right here, so the number you're going to put right here, this H right here. See my teacher have something. Hold on there, guys. See my teacher with something. Him have this thing him use. Give me a second. Him have this thing him use. Give me a second, guys. Guys, I can't seem to move my screen. Hold on. Let me stop sharing. Let me try again. My screen got stuck a while ago. Okay, it's back. Okay. All right. So the formula for H is going to be, I'm going to put it on this side. So the formula for H is going to be equal to B over 2A. All right, B over 2A. All right, and again, you can see that this B right here is this B right here. So this B, the number you put here, is the number that's right here. So, all right, so we're going to put this in a text box, a little box right here. And then now we have the formula for K now. The formula for K now is going to be, so K is equal to 4AC minus B squared over 4A. Geneva? Okay. All right, so put this in a text box. Okay, all right, cool. All right, so those are your formulas, guys. So A is equal to A, H is equal to B over 2A, and K is equal to 4AC minus B squared over 4A. In a bit, after doing it so many times, you'll catch on to these little things. It won't be nothing too hard. All right, let me give you an example of what we're doing. How much time we have there? 40 minutes? Okay. Here's how the question is normally written. Normally. Generally. So it normally says, express the following. No, can't. Okay, sorry. We can't type it because I wouldn't be able to get the x squared on the front. Okay, so I'm going to write it instead. So it's going to say x. Express five x squared. Sorry, I put a symbol before that. They say express f of x, which is equal to 5x squared minus 4x plus 2 in the form a open bracket x plus h all squared plus k. So you have to express f of x 5x squared minus 4x plus 2 in the form a open bracket x plus 8. Let me write this a better. Oh my god. All squared where a, h, and k are constants. Geneva, do you remember the paper that we did you remember the paper, the year of the paper that Sterling had said that we found the question today so I could show my students? 2017? Okay. She said 2017, guys. Give me a sec. I want to show you what it looks like. So you see how I wrote the question a while ago? Look at the screen. Express f of x blah 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 in the form of blah 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 where a, h, and k are constants, right? Okay. So I'm going to show you on the screen. She said 2017. I want you guys to see it, how it looks on the paper, because maybe you guys have never seen it before. All right, so she said 2017, right? 2017. All right, scroll up. Okay, must be May, June. It's coming up, guys. Look for it. It's on the screen. I think I passed it. Passed it? Is it it says 2017 January? Or was it 2017 May? Because I'm not seeing it here. It may be January. Hold on. 2017 May, must be 2017 January. All right, let's see. There it is, guys. Can you guys see it?
Yes, sir.
So that's what it looks like. You find it at question, look, you find it at question 9. That's where it normally pops up. Question 9. It's right here. So you see that right there. Right, blah, 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 in the form, that's something there. You see it? Right there, so. So I want you guys to see it on an actual paper, so you know, so yeah. All right, lovely. Lovely, lovely, lovely. Sorry, guys. I lost my whiteboard.
So, sir,
Yes, go ahead.
is the a all squared x plus h plus k provided, or is that
Yes.
something you need to remember?
Oh, no, man. They tell you that they want it in that form.
Okay.
All right, so go ahead now. Ready? So using the formulas up here, ladies and gentlefolks, we'll do 2 examples. I might go over time. All right, so using the formulas up here that we have, we're looking for these values here. Look, we're looking for A, we're looking for H, and we're looking for K. Those are what we're looking for. So right away, using this formula up here, we know right away that this small a here is going to be equal to 5. So you know that. Look at this. Then we said this small a, look, this small a is equal to this big A. So this small a right here is equal to this big A right here. But look at the big A that's right there. 5. That's how we know it's 5. That's it. Okay? Now H. H now is equal to, look at the formula for H, B over 2A. B over 2A. B over 2A. Now, look at where the B is. The B is right here. It's in front of the X, not true? So which number is in front of the X right here? Negative 4. So that's going to be equal to negative 4. And that's going to be all over 2 times A. And A is going to be, we just say A is what? 5. So this works out to be negative 4 over 10. All right? 2 times 5 is 10. So,
Then you switch and get kicked off.
pardon me?
Because I'm not seeing your whiteboard.
It's been shared. So you have to. Is there any? I don't. No, everybody has to see it. You have to jump out and jump back in the class.
Each
To be
time
an-
you switch to the past papers, that's what I have to be doing.
Oh, okay, okay,
I
all
don't know
right.
why that is happening.
Probably from my end though. All right. So you've seen it now though.
Oh, no, we have to come out and come back on again.
All right. I'll stop doing that though. All right. So H is equal to B over 2A. You can see that B is negative 4. Look at the negative 4 here, right here. That's negative 4 right here. Negative 4 there. That's the B. And then that's going to be 2 times A is 5. When you work out that, you can leave it as negative 4 over 10, but I feel like that's just very uncomfortable because something can go in at that, no, sir? So we can say 2 into 4 goes 2 times and 2 into 10 goes 5. So we end up with negative 2/5. All right. And then finally now we end up with H. So we find out with K, sorry, K. So K works out to be 4AC minus B squared all over 4A. All right, so it's going to be 4 times, we said A is, look at it, A is 5. Right? And C is 2. Look at the C right here. Look, the C is at the end up here. See the C right as well? The C there? And it's all by itself. So that means when you're looking at the equation, C is right there by itself. That's 2. So that's 4 times 2 minus B squared. We just said B is negative 4. So that's negative 4 squared all over 4 times A. And that's going to be 2. 4 5s is 20. 20 times 2 is 40. 4 times 5 is 20. 20 times 2 is 40. Minus negative 4 squared is 16. And that's going to be all over 8. 2, Geneva. 2, C is 2. A is 2. A is 5. But that's what I wrote here, Geneva. 4 times A times C. Now let me do. What did I do wrong? It is 4AC, right, Geneva? And it's 4 times A is 5 times C is 2. I do something wrong? Man, are you the foolishness and not try mislead me, no, Geneva? All right, let's go. So 40 minus 16, that's going to give us what? 24. And 24 divided by 8 works out nicely to be 3. Hold on. Yeah, to be 3. Okay? So, now that we have the answers, let's put them in red. So we have A is equal to 5. And we have A is equal to 5. Oh, 4 times. Hold on. C is. Geneva, I'm not sure if I'm understanding you correctly. Because this is saying. Let me just make sure. Let me take it out. Hold on. We know that A is 5. And we know that B is -4. Oh, thank you so much. Right. So she's saying, guys, that I had 4A down here. She said I have 4A down here. And I wrote 4 times 2, but A is not 2, A is 5. Thank you, Geneva. It says 4 times 5. Thank you so much. So that means it's going to be 24/20. This is not over 8. I wrote 4 times 2 instead of 4 times 8. Sorry, 4 times 5. Because A is 5. Look, the formula is 4A, and it's 4 times A, but A is 5 right here. So I made a mistake. Thank you, Geneva. So 24 divided by 20. Don't use any decimal. Let's use, right. So we can just say 4 into this goes 6 times, and 4 into this goes 5. So end up with 6/5. All right. That's it. All right. So now that we have A, and we have, so look at this now. We have A, which is going to be 5. We have H, which is -2/5. And we have K, which is 6/5. Our answer is we're gonna put row, we're gonna put them back in the position. We're gonna put A here, we're gonna put H here, and we're gonna put K right here. So A is going to be 5, open bracket. We know we never find X, so write it back. We found H to be -2/5, all squared, and then we found K to be +6/5. And that's it. So notice what we have now. We have what? A, open bracket, X plus or minus H. In this case, it is minus. It says A, open bracket, X minus H, all squared, you can see it, +6/5. And that's it, plus K. All right, but due to the importance of this, as per usual, when I come to the next class, I will be doing recaps, right? So I'll be running through more examples of this, right? And then we're going to be extending it. After we are comfortable in doing this and putting it into that form, we're going to use it to draw the graphs, sketch the graphs, draw the graph, and answer some quite interesting questions. Okay. All right, so just as a quick reminder before I go, remember, students, that I will be loading up some SBs on some disk. Do your very best to get them down to the school on or before Friday, because I'll be burning CDs all day on Saturday. I'm gonna come out from 9 o'clock in the morning straight up until probably when the school closed, 4 o'clock. So I'll be burning CDs. So whichever SBs you are wanting me to do, just bring them down to the office, bring the CDs, and you just email the respective subjects to the email that was sent in the group. Okay? And remember, I'm not going to be here on Saturday. I'm taking a break to do this. And then now, so the week after that, so it's going to be the beginning of revision. All right? We're going to be doing some real questions now, live questions. Okay? All right, have yourselves a good evening, everybody. Be blessed, and see you guys next week.
Thank you very much, sir. Thank you. And good night as well.
All right, bro. Good night. Ain't nothing we can say bye before they go away. Sure.